up, y'all? So let's go over ionic bonds. Ionic bonds is the attraction made after one atom transfers its electrons over to another atom. The attraction between those two new ions is what creates ionic bonds. Okay, so an ionic bond is an attraction between two ions. That's how it goes. So an ionic bond, as it was just written, requires the transfer of electrons. And for example, if we have our table salt, NaCl, here's what it looks like. So Na is positively charged, and then Cl is negatively charged. Okay, and the attraction between these two is what's the ionic bond. This attraction that occurs after these both become charged is the ionic bond. Now, the way this happens is that if we look back, all atoms are trying to fill the outermost, it's called the octet rule. They want to fill and they want to have 8 valence electrons. So they want to have 8 electrons in the outermost shell. So if we look at sodium, it has 1 valence electron. I'm using the Lewis dot structure for these. And then chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Now, in order for chlorine to have 8 valence electrons, it needs 1 electron. And in order for sodium to basically go down a level, energy level, where it already has a filled energy level, it needs to get rid of this 1 electron. So it sees chlorine and it's all like, yo, you're gonna have some of my electrons. Chlorine's like, yeah, let's go, big boy. So I don't know what. So sodium transfers its electron over to chlorine. Okay, and after that, sodium becomes positively charged, chlorine becomes negatively charged. And since positives and negative things attract to each other, opposite charges attract, the attraction between them makes the ionic bond. Okay, and to give another example where instead of only having one, there is also, what do you call it? Where did that example go? Here we have magnesium. Magnesium, 1, 2, draw it up here. 1, 2, and then we have 2 chlorine. 2 chlorines. So it doesn't always have to be between one atom each time. So magnesium transfer 1 electron here, 1 electron here. So then magnesium has a positive 2 charge. Chlorine has a negative charge, and then this other chlorine atom has a negative charge. And they get attracted to the magnesium, and that creates the compound magnesium chloride. What's it name? Yeah, I don't know the name, but that's what gets made. Alright. So, and here's another trend that we see. So in ionic compounds, it mainly involves it usually occurs between metals and non-metals. So these are all the metals right here. These are all the metals. And these are predominantly the non-metals. There's metalloids along here as well, but these are where the non-metals are located. And the reason why is because these metals, they only have 1 to 2 valence electrons. They're trying to give away their electrons as much as possible because they have so few of them that once they give them away, they can go down an energy level which is already filled with electrons. These non-metals, they have almost a whole octet or 8 valence electrons, but they may be off by 1 or 2. Like for example, all these are off by 1 valence electron, all these are off by 2. So they're really wanting to get a bunch of electrons, not a bunch, but enough to fill the outermost shell. That's why you'll see that these, for example, the first column and column number 1 and column number 17 will be group 1 and group 17 will be reacting very well. Like these are very reactive. Group 1 elements are very reactive because they want to give away their electrons so badly, and group 17 elements are very reactive because they want to take that 1 electron in. But so mainly metals give electrons, and then non-metals take electrons when you're talking about an ionic bond. Okay, so just to summarize, ionic bonds involve the transfer transfer of electrons from one atom to the next, and after the two ions are created, or however many ions are created, the attraction between the ions, between the positive and negative ions, make the ionic compound. Yes.